Good afternoon. I am going to discuss about circular convolution by concentric circle method. So perform a circular convolution of x of n 1, 2, 3, 1 and h of n 1, 1, 1 using concentric circle method. So in linear convolution, the number of samples it's not required to equal. So h of n different number of samples, x of n different number of samples you can process. But in case of circular convolution, the number of samples should be equal in both the sequences. So in the first sequence, I am having 4 samples, but in second sequence only 3 samples. So I should add at the end 1 0 to make the number of samples are equal in both the sequences. So I can add after 1, I can add 0 here. Then the formula for the circular convolution is y of n equal to k is equal to minus infinity to infinity x of k h of n minus k. So among these two sequences, one sequence I can take it in the outer circle, another sequence I can write it in the inner circle. So I am taking x of n in the outer circle. So x of k equal to 1, 2, 3, 1. X of n, I can write it in the anti-clockwise direction. So I can start here 1, 2, 3, 1. Again, the h of, first I want to calculate y of 0. So n is equal to 0 means h of minus k. That's why in the second sequence, I write it in the clockwise direction. That is mirror image of the anti-clockwise sequence. So I can write it opposite direction means I will get h of minus k. So 1, 1, 1, 0. Then you multiply sample by sample. 1, 1, 1. Then 1 into 1, 1, 1 into 3 plus 3, 0 into 2, 0. So I'll get y of 0 is equal to 5. Next, I want to calculate y of 1. So y of 1 means x of k, h of 1 minus k. So again, 1 samples x of n, right, as it is. H of n, you can shift 1 samples in the anti-clockwise direction to get h of 1 minus k. So it shifted in anti-clockwise direction. So what it will happen? This 1 will comes here. This 0 will comes here. Then this 1 will comes here. This 1 will come here. So one sample shifted. So I got h of 1 minus k, x of k. Then multiply sample by sample. So 1 into 1, 1. 1 into 1, 1. 0 into 3, 0. 1 into 2, 2. So totally 1 plus 1 plus 2, 4. So y of 1 equal to 4. The next I should calculate y of 2. So y of 2 means x of k, h of 2 minus k. So this is h of 1 minus k. So with respect to this circle, again one sample shift in the anti-clockwise direction. That will give the h of 2 minus k. So see, this 1 will be shifted here. This 1 will be shifted here. This 0 will be shifted here. Then this 1 will move here. Then you multiply sample by sample. 1 into 1, 1. 1 into 0, 0. 1 into 3, 3. 1 into 2, 2. Equal to 6. Next to find out y of 3. So again, shift this circle h of n, one sample in the anti-clockwise direction to get y of 3 minus k. So it shifted one sample. Again, multiply sample by sample, you will get y of 3. Then finally, you can write the sequence y of n equal to 5, 4, 6, 6. So in case of linear convolution, the number of samples in the outputs will be n1 plus n2 minus 1. That is number of samples in the first sequence plus number of samples in the second sequence minus 1. But in case of circular convolution, the number of samples will be equal to the number of samples in the input. So you want to verify this answer. So for that, you can use the matrix method for verification. So you can take one sequence in the first column. So I can take 1, 1, 1, 1, 0. So initially it's given 1, 1, 1, 0. So you can write 1, 1, 1, 0. Then this 0 will be moved here. Then you write 1, 1, 1. This 1 will be moved here. Then write remaining digit as it is 0, 1, 1. Then this 1 will be moved here. Write the remaining digit as it is. Then second sequence is 1, 2, 3, 1. Write it as a column vector. Then multiply the first row and call this column. You write it here. So 1 into 1, 1, 0, 1 into 3, 3, 1 into 1, 1. So 1 plus 3, 4, 4 plus 1, 5. So like matrix multiplication. So you multiply this. Next, this second row by this column. So 1 into 1, 1, 1 into 2, 2, 3, then 0, this 1. So 4. Similarly, multiply third row and this column. Fourth row and this column, you will obtain the vector 5, 4, 6, 6. That is the output sequence. So this is the circular convolution performed with concentric circle method. Thank you.